Okay, my friends, I was contacted by someone that wants to do a PhD doctoral on mud fossils, and I'm totally down with that. I have lots of information. I have specimens, DNA certified, I have the DNA tests, and I think it's time to start looking at them. This was that, just what I showed you was certified. This was a lung, that's a human lung, was also certified mitochondrial DNA, a human. And I had one from a giant, and that is the fingerprints off of that giant's fingertip. And this is where that giant's fingertip is, right here. It's out in my backyard. And this I broke off over here. This is the fingernail. It's actually absolutely pristine. And this is what happens to them. They come off in each little bone is wrapped in what they call tunica. Now here's one here, a small one obviously, but it's wrapped in that same fabric, which is a tunica they call it. You see that little angular shape there? They all have the wraps around, even on the toes. And I can show you a toe over here, I will right now, that has that tunica. Alright, now this is a giant toe from a giant human, and that is the toe. This is where the toenail was. And I say it's a toe because that is the callus on the guy's toe. Right? And that, I just told you, they have this triangular looking stuff. If you could see it, it's a triangle. This is the callus. Right? That right there is where the vein came in. And the vein blood is black. In us it's blue, but when it turns into the oxygen, it turns black. And that's what this is here. That would normally never, ever leak out. The only reason the black blood leaked out in this case, the vein blood, instead of the red, is because the red blood side, which is here, is capped over. You see that? Can you see that with the, yeah. You see that? That's the callus right there. That's the guy's callus. This is the bottom of the toe. This is called grip skin. It's on the bottom of your fingers, your toes, and so forth. And that's really tough stuff. It's got a lot of fiber in there, and I believe it also has iridium. Now I know it's got a lot of real tough stuff, because that's what it's doing. It's interacting, it's gripping, it's a real tough, and I think there's iridium in here. I'd love to have it tested for iridium. Now, that is also a pad on the bottom of the toe, just like you have on your own toe. That's what it is. Now, again, the red blood didn't blow out, but this red blood is right here. And they all have this big saturated red spot in the right up in the front where the toenail is. Now, I have another one around here that shows how the blood blows out. Here it is right here. This is a finger, but what happened is the vein does not blow out. You see they're restricted here. That's the vein. The artery side blows out. Boom, boom, and boom. It runs down and goes like that. The vein is over here. The red blood works its way over into the black blood side, but the black blood cannot go backwards. It's got clamps in there. Now, I have so much of this stuff, and I'm not going to go through it over and over and over. I've done it so many times. It's just time to start looking at it. I mean, I have goose. That's a goose, or a duck, some kind of mallard duck or a goose or whatever it is. That's the feathers on his head. Shown that a number of times. There's the no-toes. It's a brand new species. Nobody knows about them. They have toes inside of them, but they don't stick out. Call them no-toes. See it? And that is the way the skin covers up, and it makes that round pad in the front there. I don't know why. But that's just skin. That is not like a shoe. And I have a friend, Tish Egerton, has tons of these. She's found a site that is just loaded with them. So, whenever anybody wants to start taking a look, there's a lot of looks to be taken. Okay, I am going to show you, this is the site. It's not complete yet and it won't be up for a while. And when it's done, it's going to be just about mud fossils and all of the other research that we had to do to prove our points. And it became amazing. We had to get into light and particles. We had to get into, all of how these mud fossils preserve and why they become the way they become. How did this happen? Why didn't they rot? Well, they didn't rot because they were in salt water. And how gigantic were they? Well, they were gigantic. This guy is washing this off. They're going to cut it off and make somebody's a bunch of tabletops. And what is all of the different minerals and metals and elements that we find, and why are they in the concentrated places that we find them? All right, we got a lot of looking to do. So let's look at the DNA. Let's just start there. Again, this is not up yet, but it'll be up before too long. This is a DNA report. It goes back 5 years or so. And it's undeniable. There was 3 samples sent, and I showed them to you already, or I will. I'm sure I already showed them to you in this. And here they are. There was 3 samples. There was a lung and 2 from a giant. The lung was a normal size. And they all came out as human mitochondrial DNA. 2 of them were dense. 1 of them wasn't as dense, but it did have enough to show what it was. And there they are, Homo sapien mitochondrial cytochrome B gene, Homo sapien mitochondrial D-loop region. Now, what does that mean to us as far as proving it's human? It proves beyond a shadow of a doubt it has the exact same, well, I'm not sure it's 100% exact same, but the mitochondrial DNA is the same as ours. That's what I was told. Which means that it came from the same mother species. Right? Mitochondrial means a mother. And we all have the same mitochondrial DNA, and so did they. That's what it is. And these are all the CTAGs, which is the chromosomal configurations. This was a certified test. It was, it wasn't cheap, and it took a while to do, and it was done with ancient protocols. So now is the time to look into this for its trueness, and not just avoid it because it's inconvenient.